Intro Algebra Lesson 2-5B. We were discussing what to do with positive and negative numbers when we multiply, so we're going to keep working with that a little bit. Our first situation as an example would be to evaluate this expression given a value for x. Now this is hard. People mess this up all the time. What they do, what you're supposed to do, is you're supposed to put this entire value anywhere you see an x. What that means is replace the x and only the x with that entire value. Unfortunately, what a lot of people do is they notice that that's a -4 and they see it negative right here, so they think they just already have the negative taken care of, and they write it like so. This is going to produce possibly or potentially problems for you because you actually haven't substituted the value in correctly. Now it may not make a difference coincidentally, but you don't want to practice the wrong thing. Let's go back and let's look at this right here, this expression to begin with. Another way of saying this is not negative, but opposite. You've got to recall that this sign right here means opposite. So we are saying we want the opposite of whatever x actually is. Now right now, x is a -4. So the opposite of that -4 would actually be +4. That's very tricky for people. So just remember, these both mean opposite. So if I actually substituted it in, it would look like this. 2, and then there'd be a negative for the opposite, and then I'd have the -4 in here. Because that's the actual x value. This 2 is still here, that parenthesis is still here, that -4 is still here, or this negative is still here, and the -4 is the x. And I'd have the exact same thing over here. But because I'm thinking of this as the word opposite rather than negative, I don't want to say -4, I'm going to say this is the opposite of -4, which will produce a positive. So now I have 2 times 4 times 4. The whole problem is positive in this case. 2 times 4 is 8, and 8 times 4 makes 32. So when I actually evaluate it for this, then I'd come up with 32. Now let's say that was a -4. Pretend it was +3. If it were +3, you'd stick it in here, and the opposite of 3 would be -3. And so you'd have 2 times -3 times -3. I don't care what the value is, stick it in, and don't assume because it already has a negative sign that you're good. That's actually going to end up changing whatever you plug in there. So if you plug in a positive, it's going to change it into a negative. If you plug in a negative, it's going to change it into a positive. Just watch those signs extremely carefully. Attention to detail. Alright? We still have an x value of 4. So, or a -4. If x equals -4, then we're going to stick it right there. Alright? So we have -5 being multiplied by -4. And we have the fraction -2/7. So that's the appearance of the problem right now. Because it's multiplication throughout the entire problem, it doesn't matter the order that you multiply in. But 1, 2, 3 negatives is going to equal a negative answer. So now that I know it's a negative answer, don't stress about the signs. Just do your multiplication like you normally would. You'll notice when I do these, I first look at it and see if I can determine whether it's positive or negative. Then I worry about the math. You can make each one of these a fraction by putting a 1 underneath it. And you can multiply the 5 and the 4 and you get 20 over 1 being multiplied by the 2 over the 7. Notice I am not even worried about the signs anymore because I already know the answer is negative. If you want, go ahead and keep the negative here. Fractions multiply straight across, so you end up with -40 over +7. And you can leave it as an improper fraction, or you could convert it. 7 goes into 45 times, so it would be -5 with 5/7 left over. Either answer is acceptable. It's up to you. Just be cautious. You're plugging the value in, make them fractions, and then you know how to deal it. I know I want to make sure that you understand this -2/7 real quick. If you have the negative sign in the middle of 2/7, it's saying the whole fraction is negative, which means it doesn't matter if you give it to the top number or if you give it to the bottom number. But you cannot give it to both. It does not equal when you give it to both. Either in the middle, top, or the bottom. Take your pick. It won't matter. Just don't give it to both the top and bottom numbers. Alright, another example. Evaluate the expression when x is equal to -3. So we're going to stick that -3 here and here. So what I'm going to do is replace it. Now I have the exact same problem. I just replace the x's with exactly the value that they gave me. Everything else stays exactly the same. If you notice, 1, 2, 3. 3 negatives will equal a negative answer. I know that to be a fact. Multiply in any order you want. 1 times 3 is 3, 3 times 3 is 9. Now 3 times 3 is 9, 9 times 1 is 9. That 3 times that 1 is 3 times 3. It doesn't matter. It's always going to produce the same. I know the answer is negative. So I say that when I've evaluated it, it's -9. A story problem involving a grocery store that runs a sale where customers can get 2 bags of spinach for the price of 1 bag of spinach. In other words, they're still selling the regular bag of spinach, but they're giving a free one away. The store normally charges $1.69 per bag. How much will they be losing in sales if they give away 798 free bags? Now remember, losing is like negative money. They're losing those dollars. So wait, that $1.69, we're not making that money as a store. We're losing $1.69 on every one of these bags. So you could go ahead and go $1.69, which is actually negative, and multiply it by 798. We already know that a negative times a positive is going to make a negative answer. We know the answer is negative. 8 times 9 is 72, carry the 7. 8 times 6 is 48, plus the 7 is 55, carry the 5. 8 times 1 is 8, plus the 5 is 13. Now, it's important that you bring a 0 down before you start the next round. 9 times 9 is 81, carry the 8. 9 times 6 is 54, plus the 8 gives us 62, carry the 6. 9 times 1 is 9, plus the 6 would be 15. Okay? This time you bring 2 zeros down. Each sequential number you move over, you bring another 0 down. 7 times 9 is 63. Carry the 6. 7 times 6 is 42, plus the 6 is 48. Carry the 4. 7 times 1 is 7, plus 4 is 11. Now, you add them all together, straight down, 2, 6, 3 and 3 plus 2 is going to give us 8, 6, 14, carry the 1, 3, and 1. It's a pretty big number. I haven't looked at the decimals yet. There are 2 decimals to the right of their number in this entire top problem, which means there need to be the same number to the right of mine. So we would say there's $1,348.62 that they've lost. So we'd say that's negative dollars. Let's test it and make sure I've done it correctly. $1.69 times 798, $1,348.62. And it's lost money, so it's negative $1,348. So negative dollars. And our last example, a paper airplane descends. When something descends, it's going to go down. So descends means going down. If we're going up, that would be ascend. It ascends. Velocity, if you recall, is speed and direction. So we're going down 14 inches every second. So you throw the paper airplane, and as it's flying, it drops 14, 14, 14, 14 inches every single second. Find the vertical distance traveled in 7.5 seconds. Vertical is up and down, so we really want to know how much did it drop in 7.5 seconds. Well, take the 7.5 for how much time there was. And you can write that as a fraction, 7.5 seconds over 1, and multiply it by the negative 14 inches per 1 second. Now fractions work so that if there's something on top and bottom, they cancel, and you'll notice that there's the unit seconds and seconds on top and bottom, so they're going to cancel. You have a positive times a negative. You have one negative sign, so your answer is going to be a negative answer. And it's going to be a negative answer in inches. Fractions multiply straight across, so 1 times 1 is 1, we don't need it. You do the 7.5 times the 14. You can do 7 times 14 is the same as 7 times 10, and then 7 times 4 put together, which would actually, 7 times 10 is 70, and 7 times 4 is 28, so we're talking about 98 there. And then the half times 14 is another 7 more, so 98 and 7 should be 105. Let's test. 7.5 times 14, and we end up with 105. So we were correct. So it's negative 105 inches. So you've got this paper airplane and you throw it, and it drops 14 inches every second. If that happened for 7.5 seconds, it would drop 105 inches total. Alright? So here are some little story problem scenarios. You'll probably get some problems that are similar to this. Just remember, find the important pieces of information, set them up if you need to so that units will cancel, and deal with fractions while multiplying straight across. You still have the same rules where you count up how many negatives you have. If you have an odd number of negative signs, your answer is negative. If you have an even number of negative signs, your answer is going to be positive. Same rules apply even though it's story problems.